we will solve the convolution integral for signals x1 and x2. The integral asks for changing x2 from t to tau. This is an easy substitution since x2 is not a function of time. Part of the integral is asking us to substitute t by t minus tau in x1. This substitution will time reverse x1 and slide it for different values of time. Let's take a picture at t equals to 0 as the arrow indicates. For values of time different than 0, the sliding happens. We see that at these values of time, the product of those two signals is equal to 0, as there is no overlapping between them. This is true until it reaches this point, which is equal to t equals to 1. As t goes beyond minus 1, we see that we have some overlapping and the product is no longer 0. This is highlighted with the green area. Thus, the integral should be valid from that point, minus 5, all the way to t minus 4. The evaluation of this integral is only valid until t is equal to 0. After this time, we need to substitute the integral limits, as the green area doesn't change during all this period, for t greater than 0 all the way to t equals to 1. After this time, we need to change the limits of the integral once again. As you can see, the green area is changing. This will remain valid until time equals to 2. Afterwards, there is no overlapping and the convolution is equal to 0. Let's plot the solution. Let's modify the example so that we can see the substitution of t by t minus tau. x1 will do the time reversal and sliding. The limits will be the same and the integral shouldn't change in the limits. It's just the integral itself, the function evaluating, that changes. Note that we are integrating over tau, so the term e to the at can be seen as a constant. Recall the commutative property of convolutions, which means that in that integral we can choose x1 or x2 as the one to be doing the time reversal and sliding. If we choose x2, we can see that the integral will be much easier to solve. The solution we obtain by doing this must be the same.